Okay. All right. A sequence, just get some, so a sequence is nothing more than an ordered list of numbers. Terms are each number in a sequence. Each number in a sequence. So your sequence will go a sub 1, a sub 2, a sub 3, on and on and on, till a sub n. And before a sub n would be a sub n minus 1. And apparently I need to maybe charge this more. So, oops. Okay, so a sub 1 is your first term. So it says identify the pattern. So we can see the pattern here is timesing by 2. And then it says find a sub 3. So pattern, I would say times by 2. And a sub 3 just means the third term in the sequence. So it would be the 12. Okay, that's your third term. And here we can see the pattern is subtracting 3. So we would just write that down. Subtract 3. The a sub 6 would be the sixth term in our sequence. So after negative 8, we would have negative 11. And then we would subtract 3 again to get negative 14. And subtract 3 again to get negative 17. So this is 1, 2, this would be the sixth term right here. So a sub 6, the sixth term of the sequence, would be negative 17. All right, let's take a look at the next thing. It says find the first 4 terms defined by each formula. So an explicit formula, if you want a sub 1, you just put 1 in for n. So a sub 1 equals negative 2 times 1 plus 5, which would make the first term 3. Then a sub 2, negative 2 times 2 plus 5, which would be 1. And you would continue this pattern. A sub 3 is negative, oops, let me go backwards here. This would be negative 2 times 3 plus 5, negative 1, and so on. A sub 4, negative 2 times 4 plus 5, that will give us negative 3. So our sequence would go 3, 1, negative 1, negative 3. All right, and again, you can see that this is the sequence here, the pattern is that we're subtracting 2. So recursive formula, they always give you the first term. So a sub 1, they're going to tell you it's negative 6. To get your next term, a sub n, use this formula for anything a sub 2 or bigger. So a sub 2, you're putting 2 in for n. So a sub 2 minus 1 would be a sub 1 plus 4. So we can plug our a sub 1 in, that was negative 6, plus the 4 is going to give us a sub 2 is negative 2. So now, if I wanted a sub 3, the third term in the sequence, a sub 3 is a sub 3 minus 1, which is a sub 2 plus 4. So we're always taking the previous term, so a sub 2 is negative 2, and we're adding 4, that's going to give us 2 for our third term. And we would follow through with for a sub 4. A sub 4 would be a sub 3 plus 4. A sub 3 is our previous term is 2. We're going to add 4. That would be 6. So our sequence is going to go negative 6, negative 2, 2, 6. And we can see the pattern there is adding 4. So let's move on to our next slide. Arithmetic sequence is one in which you either add or subtract to get the next term. to get the next term, yeah. All right, and they say there's a common difference D. So it says, is the given sequence arithmetic? So we're looking to see if there's a common difference. So here we can see we're adding 3 and then we're adding 2. So there's not a common difference, so this would be not arithmetic. The second one, we can see the pattern is that we are subtracting 3. So this one is arithmetic. And the common difference is -3 since we're subtracting 3. Find the 50th term of each sequence. So first of all, we can see the pattern here is that we are adding 11. We are adding 11 again, and so on. So this is an arithmetic sequence in which your D value, your common difference, is 11. So if I wanted the 50th term, and I'm starting with the first term being 2, and I keep adding 11, how many times would I have to add 11 to get to the 50th term? Well, I'm already at the first term of 2, so I would have to add 11 49 more times. So this would give me my 50th term, which is going to be a sub 50, 541. Okay, so the same thing would apply for B. We're subtracting 13, so keep doing that, so my common difference is 13. So if I wanted the 50th term here, I start with my first term, a sub 1, which is 26. And I'm going to subtract 13. How many times to get to the 50th term? I would subtract 13 49 times. Subtract 13 49 times. That's much better than having to do minus 13 over and over again 49 times. So if I do that, 26 minus that, I would be at -611. All right, a couple more to go here. Explicit formula, a sub n, to get any term in the sequence. We are going to take the first term, a sub 1, and we're going to add the difference, n minus 1 times. Just like when we wanted the 50th term, we added the difference 49 times. The recursive formula has 2 parts. The first part is a sub 1 is the first term. That you need to give. And then the second part is a sub n equals a sub n minus 1 plus your difference. So a sub n minus 1 is the term before a sub n. We denote that as our previous term. So you're always taking your previous term and you're adding a difference. Let's take a look at the sequence. So the pattern is that we are subtracting 4. So if I wanted my explicit formula, I would say a sub n equals a sub 1. So my a sub 1 is -3. And I'm adding d, the difference. My difference here is -4. So basically I'm subtracting 4 how many times? N minus 1 times. So whatever term I want, I'm going to subtract 4 one less time. So I'm probably going to want to clean this up and distribute. So -3 minus 4n plus 4. Add my like terms. So a sub n is going to end up to be -4n plus 1. So this formula now I could use to find anything. Like 100th term, I would do a sub 100, and so on. The other one is the recursive. Recursive needs 2 parts. You need to tell the person the first term. So a sub 1, that's my first term. You got to tell them it's -3. And then the second part, a sub n, To get any other term in the sequence, you take the term before a sub n, the previous term, that's denoted a sub n minus 1. And what do you want them to do to the previous term? You want them to subtract 4. So this just means previous term and then subtract 4. So there's your, this whole thing here makes the recursive. You need to have two parts. So we would do the same thing on this problem. Our common difference would be adding 1/8 repeatedly. So D equals 1/8. My explicit a sub n equals a sub 1. A sub 1 here, my first term is 0, plus my difference, 1/8, times n minus 1. Now you could leave it like this, the 1/8 times n minus 1, or we could take the time to distribute it through. A sub n equals 1/8 n minus 1/8. So that would be probably the way you probably would want to do it. Recursive is the two parts again. So a sub 1 equals the first term. You always have to give the first term. And then to get a sub 2 or anything higher, you would do a sub n equals a sub n minus 1. And then you always want to put plus your difference. In this, well, this case, it's going to be plus 1/8 because you're adding 1/8. So this would tell you if you wanted, for example, if you wanted a sub 2, you would do a sub 1 and add 1/8. So that would be just taking 0 plus 1/8. So your second term would end up being 1/8, which we see in our sequence that a sub 2 is indeed 1/8. It works. All right. Arithmetic mean is used to find the missing term in an arithmetic sequence. So if you have an arithmetic sequence, when they're telling you there's a common difference, in order to get that middle term, you are just going to, they call it a mean because you're averaging. So you're just going to take 50 plus 92 and average that out. So that's going to end up being 142 divided by 2, which is going to be 71 would be your missing term. So it says find the missing term, which we did, and then state the common difference. Well, what is my difference? To get from 50 to 71, I'd be adding 11. To get from 71 to 92, I'm adding 11. So my common difference is 11. And to finish up, suppose you already have $75 saved towards your purchase of a new iPod and speakers. You plan to save at least $12 a week from the money you earned at a part-time job. In all, what is the minimum amount you will have after 26 weeks? So if we start off with, we can model this with a sequence, $75. And then after 1 week, we are going to have $12 more at least. So that is going to put me at $87. And every week thereafter, we're going to be adding another $12. So don't get too caught up in the notation here. Basically, this means if you have $75 and you're adding $12 a week for 26 weeks, you're going to be adding 12 at least 26 times, or exactly 26 times. So the final amount is going to be $387. So you're adding 26 times once a week. So add $12 26 times. That's one time per week. Okay. Well, thank you for listening. I know this was messy and I probably talked too fast, but probably better than not having any verbal instruction. So I will go over questions on Monday. All right. Have a good one.